And I appreciate that you are still here. So it means that the first part of my talk was pretty good. So at least that's how I read things. Okay. So if it's different, don't tell me. Okay. So now the question is, can I execute multiple calculations at once? Okay. And then the other question is about streaming, whether things are different for streaming or not. The simple answer is no. The same applies to streaming. That's the beauty of the brand new Spark Structured Streaming. Okay, so you should. Now I'm here to tell it again publicly that even though Spark Streaming is not marked as deprecated, just like GraphX, they are dead. Okay, why they are dead? No one is working on them. Okay, no support. So either they are so perfectly designed, or they are buggy and no one wants to look at them. And for Spark Streaming, we've got, I know, Holden and Gerard and others, are still promoting Spark Streaming. I'm here to tell you that Spark Structured Streaming will give you all the goodies that I shared about, batch processing, in my first part of my talk. Okay, so all this nicely applies to streaming, Spark Structured Streaming too. Okay, you've got another exercise, multiple aggregations. Now I've got only half an hour, and now I'm worried that I'm spending too much time on groupBy. So as you can see, we've got this, groupBy-like exercises, and that's enough. Okay, you've got also this typed groupByKey operator, and Hania or was it Hania? Yeah, Hania. Hania asked me, I apologize for this, for not remembering your beautiful name. So Hania asked me about this groupByKey. And I'm here to tell you that you should not be using groupByKey unless it's for streaming. For streaming, you've got some use cases that you cannot handle without groupByKey. For batch processing, you should stay away from groupByKey. I hope that if I'm mistaken, now Databricks will tell me that I put things wrong and I learned something today. So now my current understanding is that you should stay away from groupByKey. Why? Because groupByKey works with JVM objects. JVM objects. Spark tries to do its best, or works best when it's not working with, with objects on JVM. Why? Because, garbage collection and all this, niceties that we love and hate in JVM, will break things sometimes, or definitely performance-wise. So groupByKey is similar to groupBy, but adds this additional nice layer of type safety. So from programming perspective, it's nice to have and nice to use. But from performance perspective, it may not work so well as compared to groupBy. Okay? And my understanding is that everything that you can do with groupBy, you can easily code with groupByKey and vice versa. Okay? It's just more pleasant for Scala developers. Okay? So you've got this AGG, you've got this nice functions that are not available in groupBy, which might be the case why you need to use groupByKey. So you've got map values, map groups, flat map groups, and cogroup. They are similar to functions that are available on streaming datasets, where you can manipulate state that you accumulated over time. Okay. Okay, that's it about groupByKey. Now you've got this explaining query plans. Is there a question? Perhaps. Oh, okay. Yeah, no worries. So now explaining how to explain query plans. So what are query plans? There are 4 plans that sit behind any data set. First, there are 3 logical plans and 1 physical plan, right? Execution plan. So you've got parsed. It's easier to show rather than say, okay, so joint. Okay, now what's wrong? Because what's wrong? Come on, quickly. Yeah, you caught it. Oh, awesome. Love you guys. Okay, because I use this show, so I assigned unit nothing, so I could not use this with join, right? Oh, that's nice. Oh, yeah. Now we got this error message telling us, which is pretty good, because someone asked me about something, during our 10-minute break, and changed this ID to this, IDG. Thank you so much. Okay, so now let's fix it. But as you can see, Spark will tell you what's wrong, and if you are careful enough, if you are patient enough, you can understand where the problem is, okay? Yeah, it sometimes takes more time than you wish spend on it, but eventually you will get it, okay? And then joined, and that should be fine. Okay, good, fine. Now, the beauty of this environment and Web UI is that you can do something like explain. I love it. I love it because that opens this, beautiful world of, low-level bits and bytes that flow through the, Spark wire. So as you can see, you've got this physical plan, and that's very nice. I love looking at it. It's just like the Matrix, You look at it and you see, people walking, from one place to another, beautiful people, ladies, men, and others. So, and you've got also stars. You see? So, can you explain what this star represents? Why do we need these stars? Or asterisk? No. Optimizations. They are codegent. Okay? So the more you see this, my belief, my understanding is that the more stars, the better. Okay? Why? Why? Because you will have this code highly optimized under the covers. And you know what? You know what's the programming language they use, Spark uses for these optimizations? Java. So all optimizations, regardless of the language you are using, Python or Scala, Java, they are all transformed into code that's written, that sits behind this star that's written in Java. You want to see it? Okay. It's as simple as import debug, and let me see if I've got it in my history. No, I don't have it, so I'm not going to show you. So you just import org Apache Spark SQL debug underscore, and you will get this extra debug method. Oh, let me see. Okay, import org Apache Spark SQL, and I think it's debug. No, it's not. Come on. What was this? Who knows this? Execution catalog. Okay, not this time. Okay, so I forgot. So anyway, but by doing this explain, you will learn how Spark sees what you wrote. Okay? So whatever you write will end up as physical plan. What are the other plans? Well, it's as easy as saying explain extended true. That's the beauty of Spark and Scala. You know, Spark because it supports this extended view. Scala because you've got this named parameters where you can say what this true represents. Yes?
It was Spark SQL execution.
Oh yeah, thank you. Yeah. So so if you want to know, if you want to see this source code of Java, you know, just ask. By the way, what's your name? Roman. Just ask Roman, okay? Okay, so Roman knows. So you can do this extended view, and you can see all this nice, you know, looking stack trace-like, you know, outputs. So just get used to see them early and often. Why? Because they will tell you how Spark will execute your queries. Okay? That's the beauty of Spark, where you can have front ends in Spark, Java, Python, and R, but they all end up as this as these, logical plans. Okay, they will go through, translations and end up as these 4 logical plans. So you've got parsed logical plans, analyzed logical plans with types, and you've got optimized logical plans. This is first optimization, logical optimization, and then you've got the last but not least physical plan. Physical plan. And even though cost-based optimization is available, I'm not sure if in 2.2, but definitely it's coming. It is available in CBO, but it's disabled, and you need to enable it. So by default, Spark does not optimize your queries based on cost-based calculations. Okay, so there are no cost calculations. Just take first one, and that's it. So yeah, so it's coming. So it is available in 2.2. Okay. And the reason I'm asking is that I'm spending my time with snapshot versions from master, so I'm not sure whether it was available or it is or it's coming. So that's why I ask. Okay, all this nice looking stack traces you can find in your SQL tab. So when you go to this SQL tab, you will see all I showed you and more in this nice-looking web interface. So let's do this show here, okay? So you see, you've got this whole stage code gen. This is one of the many stars you saw in this execution plan. You've got this object hash aggregate. It's not very optimized to my understanding. There are 3 different types of aggregations, physical aggregations, and object hash aggregate, to my understanding, is not very effective. But the point is that you can use this to read some statistics, like number of output rows. So now you know that you've got 10 different groupings or groups, okay? Well, as a matter, yeah, aggregation. So range gave you 10 records. You, after object hash aggregate, you got another 10, well, same probably. Then you've got this exchange. Exchange is very dangerous. Exchange is what was called shuffle back then in RDDs, okay? So whenever you see exchange, it just shuffle, okay? So the less exchanges, the better. Okay, I'm yet to figure out the distinction between local and wide or narrow and wide shuffles. I cannot say whether it's wide or narrow, meaning whether there is network transmission or just JVM transmission between different executors. But still, just avoid exchanges as much as you can. But with groupBy, you cannot do much. You have to either approach your problem differently or just stick to at least one exchange, okay? That's the price, okay? It might be less expensive, but still you will have this exchange. And then you've got this object hash aggregate and collect limit. And this is nice, and also you can just see this logical and physical plans here. So you can just compare this with the other, and hash partitioning. You can see this 2000, which means that you've got 2000 partitions, which is the default for shuffles in Spark SQL. You can change it, but it's not obvious what parameter to use unless you know your data, which, by the way, is something very important working with Spark. You need to know your data. There is no magic going on. Spark can help you with transforming your data, but if you don't know your data, you can't do much. You won't get as performant code as Spark could give you, okay? Okay, and I wish there was this way of naming this parameter, so you know that this is the number of partitions, this 200, but there is no easy way to do it unless you rewrite this page and add some additional information. Okay, anyway, so you can just see all this, and this is pretty neat. So after this object aggregate, you've got this output rows 10, 2. So now you know that this produced 2 records. That one gave you 10, and also hovering over this box, blue box, or blue boxes, you will get additional information so you can just match it to your execution plan, okay? So this is pretty handy. Spend as much time as you can so you can optimize your queries. Okay, very good. So that's pretty much about explain. Okay, and yeah, that's pretty much about this basic aggregation. So yeah, so let's move on. So we've got windowed aggregation. This is what I love, probably because no one promotes it as much as it deserves. Okay, it means that it's pretty simple once you understand, you know, the basics of window aggregation. And sometimes it might be even faster than groupBy plus join. Okay, so use cases for windowed aggregations are whenever you see groupBy followed by join, think twice. What about window aggregation? How can I use window? And I'm not talking about window function for groupBy. I'm talking about a special way of aggregation, which I'm going to present right now. OK. And by the way, who has used window aggregation in the past? Oh, that's nice. OK. So yeah, half of the room, you know, rose the hand. Yeah, always like this. Hands. So now the question is windowed aggregation faster always, sometimes, you know, and how to compare it to groupBy, okay, and plus join. So I'm going to answer this question now. So windowed aggregation. So yeah, this is our agenda. So window aggregate functions. Window aggregate functions are pretty much what you learned with groupBy, but there are some functions, analytical functions and ranking, that you cannot use outside window scope, so to speak. So you've got these functions, and they work just like, you know, aggregate functions, but sometimes they need, you know, additional, you know, information, because window aggregate functions will give you exactly the same number of records you had in your input data set. This is unlike groupBy, where you can have at most, you will get at most the number of input records. Okay? That's the distinction between window aggregations and groupBy aggregation or basic aggregation. So for window aggregation, you will get exactly the same number of records as you had in your input data set. With groupBys, you may get at most the number of input records. Okay, good. That's output. So there is this notion of window. Window is something that's described by current record. So window is a view on your data given current record. So there is this notion of current record. So you can say I've got this cursor that walks through, iterates through all the records available, and it will give me this window that I can apply aggregation on. Okay? So it will generate, yeah, so window aggregation will generate value for every record, for every row, and that's it, yeah. Good. So what are the window functions? Well, we've got these ranking functions, rank, dense rank, percent rank. You've got entile, row number you can use. You've got these analytic functions, cum, dist, lag, and lead, which are pretty handy, not widely used, or people who are using them probably don't ask questions on Stack Overflow. So yeah, so but I don't see them very often used in answers from people who are, you know, pretty active on Stack Overflow in this Spark sphere or space. So and aggregation function, all aggregation functions can be used in this window scope. Okay, so you can use them. Okay, good. So window specification. To start using window aggregation, you need to create something that's called window specification, and it's pretty neat. And it's pretty simple, except two methods that I'm still making my mind around, meaning that there is this hidden treasure inside them, rows between and range between. who is in this class who could explain the difference between rows between and range between? Is there anyone who could explain me this? I'm close to uncover the truth, but I'm not sure how to challenge my thinking, with someone who knows how this stuff really works. So, but beside these two methods on Windows specification, there are, usual suspects like partition by and order by. Okay, they are pretty simple. Partition by will partition your data. Yes, will partition your data per groups you create or you define. Order will order, based on this ordering in every group. That's pretty simple. Now the question is about this, advanced methods, rows and range between. I'm close, but still, I'm looking for someone to explain me this. So logically, partitions data set, good. This Windows specification, you can define something that's called frame boundary or an ordering. So this frame boundary is very advanced topic described by this, rows and range between. And you use this window factory object to create this Windows specification. So it's as simple as, import org Apache Spark SQL expression.window, and then you say, okay, I've got this factory method. It's, by the way, Scala. It's not Python, not Java, not R. Look how simple Scala could be, right? So together with Spark, they create very powerful combo. So import org Apache Spark SQL expressions window, and then you say, okay, let me create artificial partitioning. Artificial meaning that I am not using particular data set, that I'm using this and these columns, they do not belong to any particular data set yet. I'm yet to somehow relate this by age tokens Windows specification with concrete example, with concrete data set, but at this point I can use whatever I want. Okay? There is no type checking in a sense that or column checking, because at this point there is no way to do it. So partition by token starts with age. So I'm pretty sure that when you look at this, it's like, I know what it's doing. It just partitioned my data set, my future data set, by token column and by values that start with age, correct? So how many groups will we have? 2, exactly, or 2, or 2. You know the difference, okay. So 2, right? Okay, good. So over column, that's how they figure out that this, American guy was not Nazi in this Inglourious Basterds, right? Remember this scene? Okay, good. So you've got this over column, and this over column operator is pretty neat because you can apply any window function using this over without specifying window specification. Over, just like groupBy, can be empty, which means all records belong to the same group, okay? So you've got this over operator, and you've got this dollar some column dot over means to apply to a window that's composed out of all the records available. And you can also define some window and use it to do something, some aggregation over a window or over this window. Okay, and then you can use with column operator to add additional column to existing columns, or you can just select. What's the difference between with column and select? With column will always add additional column, while select give you this opportunity to limit the number of columns you want to have in output, unless you use star, okay? Okay, good. So some exercises. So think about a solution using groupBy join, perhaps, to calculate first and second bestsellers across, some groups of similar topics like genre. How to pronounce it, by the way? Genre? Yeah, it's this French pronunciation I'm gonna master. Okay, so genre. So, so define window specification. This is the first step. So let me do this. And so instead of doing this first and second, I've got 5 minutes. So let's start with this join. Okay, where's our join? Okay, this is this join. Okay, good. So we've got our join here, and let's rewrite it to use window operator, okay? Window specification, window aggregation. And let's compare execution plans and see if this is better or worse than corresponding window aggregation. So we've got this collect list. So what I need is, first, I need to define window specification. So org, Apache, Spark, SQL, expressions, and window. Okay, I've got my window. And the reason I got window and window spec is because I'm using tab all the time. So that's why it showed me that there is this window and window spec that matched my letters. So import or Apache Spark. And now I'm gonna, so what was the query? Okay, it was like this. So how did this how was this sum calculated? It was groupBy ID divided by 2, right? Modulo 2. So okay, let's have it. So val, and now by window. Usually I'm more more expressive, but now I'm pressed by time, by you staring at me and the solution. So I'm very stressed. So window partition by, and now what's the partitioning? Exactly the same as I used for groupBy. This is the same, okay? So it's just like copying and pasting now, okay? groupBy. Okay, so I've got this partition by, so I partition my data set to 2 groups. Okay, good. And then, do I need order? No, not at all. Yeah, I can have it, but it's not really needed. So that's all I need, okay? So I've got my partition window specification. Now, this is the trick. Now I start with ID, with IDs, with column, and now I add new column called, what was this? It was sums. Yeah, sums. Why did we get sums with this list of numbers? We did something weird, because we applied collect list, right? And we calculated sums. Oh, that's weird. No, I usually don't write code like this, okay? So it's only during, Spark summits, conferences. So with column, sums, and now, no, it's not sums. What am I calculate? It's list, because I need to collect list. So now I do collect list over, and now I'm, applying this function over this window specification by window. Okay? And show. Hopefully, it's going to work. As it happens, it may not. Yeah. What's the problem? Yeah, exactly. So you need to specify column name. And so what's the column name? ID. That's that simple. Okay? Let's do this again. So now I did the same result. So the question is it faster than groupBy and join? So who's going to answer this question? Is it faster or slower? Or it depends? It depends on what? On data. You know what the data, what the data is. So it's going to be faster or slower? Faster. Interesting. I'm not sure about it. So usually, and my answer is, it depends on Spark version. I saw, I'm using Spark 2.2, and I know that people, in this Apache Spark project were very busy optimizing all these queries. And I saw that queries that worked or were faster previously or work differently now, okay? So it's not that obvious, okay? And since I'm independent consultant, I usually start my answer with, it depends. And it's not, it depends how much you pay. It just depends on what Spark version you use. Just that simple, okay? So let's see the console. Okay, so the console will reveal the truth, okay? So let me execute it. So ID 11. So we've got, yeah, we are over time, so we should finish now. So join. Oh, really? No. I'm not gonna do this. So IDs.show. So this is first. This is join, okay? So ID 12. Yep, it's gonna be this join, okay? Now I'm gonna execute my collect list over Windows specification. Same result. And now we've got this 13. Okay, very good. So let's compare. So by number of jobs, now groupBy and join is faster. Okay, you see? 4 Spark jobs for groupBy and join, while 5 for window. So only by this, I can say, for this particular case, groupBy and join beats window aggregation. Is it true in general? And I don't know. Is it true always? Oh, yeah. This is another angle, yeah? So now you can look at the time. You see, for four Spark jobs, you needed 0.8 seconds, while for 5 these jobs, you only needed half the time for this. So by the time, it's faster. But if you paid for CPU cycles, or for machines you need for this, jobs, you'd pay more, right? So depending on, on these factors, you may say this is faster than this, or the opposite. Look at the plans. This is the plan of window specification, or window aggregation. One exchange, okay, sort. Another window is fine, so it doesn't look, that's strange, okay? This is groupBy and join. So you've got whole state code gen here. You've got object hash aggregate, exchange. Okay, we've got exchange here too. Okay. Then object hash aggregate, whole stage code gen with this filter. You've got broadcast exchange, which makes things a little bit faster, but still it's groupBy, again, it's groupBy plus join, okay? So this range. So by seeing all these blue boxes, I'd say this is slower, right? Compared to this. So perhaps this 04, 08 might be just timing issue because, I'm running this on a local machine, something like this, okay? So it definitely needs more investigation. And I'm not able to answer this question, directly and straight, meaning that, whether this is faster than window or, window is slower than groupBy and join. But this is kind of interesting. And that's it about, advanced aggregation. I've got slides about cube, rollup, and grouping sets, but due to no time left, I have to stop now. All the slides are available on my GitHub, so if you need more information, just review the slides and let me know what's missing and what questions you have, okay? So thank you so much. If you've got any questions, you've got your time now, okay? And by the way, I'm here till 10. You don't know how, 10 p.m. or 8. How long can we be here? So 8 p.m. So 8 p.m. Not necessarily here. Somewhere over there. Okay. So if you've got any questions, just come. Okay. Thank you.